Okay, coming at you for a little bit of matrix algebra today. You got to find determinants first, then you got to find an inverse just so you can do matrix algebra. All right, determinants might be the easiest thing you've ever done. You've got your 2 by 2 matrix. Your determinant is always your main diagonal first, second diagonal second. So main diagonal, you're going to go 9 times 2. Your second diagonal is the 7 times the 3. Multiply, multiply. This is 18, this is 21, and you're just subtracting those to find the determinant. 18 minus 21, negative 3. Find a determinant, multiply, subtract your answers. So main diagonal, negative 2 times 10. Second diagonal, 4 times 6. So we've got a negative 20 minus 24. Remember, it's always subtraction. 2 answers, subtract them. Your determinant, negative 44. So to build an inverse, you have to know part of it is the determinant. Let's start building. So there's determinants. Let's do an inverse. All right, let's say you got a matrix A, 2, 4, negative 3, negative 7, 2, 4, negative 3, negative 7, and we're going to find its inverse. So we'll bring in the fancy negative 1 right there to indicate it's the inverse matrix. All right, your inverse has 2 parts. It's got an outside and it's got an inside. So for the inverse, you got to build the 2 parts. There's an outside and there's an inside. The outside is a fraction. There's always a 1 on top, always a 1 on top. The bottom is the determinant. So the outside is made up of a fraction. 1 on top, determinant on bottom. Let's find the determinant real quick. So 2 times negative 7 minus negative 3 times 4. So this will be negative 14. What is this going to be? Plus 12, negative 2. So negative 2 is my determinant. Now I'm done with the outside. The inside of your matrix has a couple rules you got to remember. Your main diagonal, the 2, negative 7, trades places. So the negative 7 goes up there, the 2 comes down. So main diagonal trades places. The second diagonal, they stay there, but you just change your sign. So negative 3, whatever is negative, change it to positive. What do we got up here? Positive 4, change it to negative 4. So this is your inverse matrix. So you could even write it really fancy here, like A negative 1 is equal to 1 over negative 2. Negative 7, negative 4, 3, 2. Look at us just showing off there. So, inverse matrix. We'll do one more. We'll do one more just to make sure we get this. Outside part, inside part. Let's do one more. Okay, so let's go number 4. Let's say we got a matrix B. We want to find him. 2, negative 3, negative 5, 9. And we're going to find the inverse. Whoops, that looks like. Let me get a negative 1. So, inverse matrix is made up of 2 parts. You got to find the inside part and you got to find the outside part. So, outside, inside. All right, your outside is always a fraction. And the top of your number, the numerator of your fraction, always a 1. The bottom is made up of your determinant. So grab this guy, figure out your determinant. Whoa, that's a lot of negative signs. Let's keep it organized. Here's 18, here's minus, negative 5, negative 3. That becomes 15. So your determinant is a positive 3. So 3 is what's going in here. That takes care of the outside. Now we have to get the inside, and the inside has 2 rules. You got the trade places maneuver. The 2 and 9's the main diagonal. they trade places. Second diagonal, they stay there, but you got to change their signs. So if it was -5, it becomes +5. If it was -3, it becomes +3. So you're wanting to find this inverse matrix? Well, we just built it. There it is. So this is your inverse for B. We're ready for some matrix algebra. All right, we've done determinant. We've built an inverse. Let's do this. Okay, here we go. Matrix algebra coming at you. So this is number 5. 2x plus 5y equals -4. X minus 3y equals 9. Okay, first step, there's 3 steps in matrix algebra. First step is you got to convert it into matrix form. You got to write it so it looks like a matrix. First one, 2 by 2, grab these numbers. 2, 5, -3, understood 1. 2, 5, -3, 1. 2, 5, -3, 1. Second one is for your letters, your variables, and then our answers in this last one. Okay, first step, run it from regular, where it looks like an equation you solve, write it like a matrix. All right, second step, we're going to grab this 2 by 2 right here, and we're going to find its inverse. Let me write it up higher where I can work with it. 2, 1, 5, -3. So we're going to find inverse. And remember, inverse is 2 parts. You've got the outside and you've got the inside. So outside is always a fraction. One's on top, determinant on bottom. Always. Real quick, let's run the determinant. So we've got 2 times -3, 1 times 5. So it looks like your determinant turns out to be a -11. So for my outside part, it's 1 over -11. All right, let's get the inside. The inside has the 2 rules. Main diagonal trades places. So 2 -3 becomes -3, 2. They trade places. Second diagonal stays put, just changes sign. +1, -1. +5, -5. Okay, first step, put it in matrix form. Second step, find this inverse. Now we're in business. We're ready for the third step of matrix algebra. I need this. All right, I'm going to get all this out of the way. I'm going to pull this guy up here where I can work with him. So 1 over -11, -3, -1, -5, 2. You guys see that okay? I think you can see that okay. So we're going to take our inverse. This is the final process. We're going to take the inverse and we're going to multiply it times our answers from the original problem. The original problem ended with a -4 and a 9. So I'm going to multiply this matrix times that matrix. Multiply matrices. The killer, though, is this fraction out here. So we're not going to mess with him until the end. So don't worry about him. We're going to multiply these first, and at the end, we'll deal with that nasty fraction. Multiply matrices, we know how this works. It's always the rows of the first one taking on the column of the second one. Let's get it. Here we go. So you've got 1 over -11. So -3, -5, -1, 2. So we've got to connect row with column, second row, column. Rows with columns, multiply matrices. -4, 9, -4, 9, -4, 9. So we do a little bit of math, get this guy rolling right here. What is this going to be? +12, -45. So is that -33? This is 4 plus 18 is 22. So I still have my nasty fraction still on the outside, but on the inside, I whittled this guy down to negative 33, and I've got 22. Let me move this up here where we can see it a little better. Okay, almost done now. Now we'll deal with that fraction. So dealing with this fraction, you've got this 1 over negative 11 multiplies here and there, but really what it is, it's just dividing by negative 11. So negative 33 divided by negative 11. 22 divided by negative 11. And it's so much easier to deal with it at the end than trying to do it back at the beginning of the process. Negative divided by negative is positive. 22 divided by 11 is negative 2. We get it down to hair. There you go. X, Y. X equals 3, Y equals negative 2. X equals 3, Y equals negative 2. Write it as an ordered pair. Matrix algebra. Ha ha! Okay, I'm game for trying another one. I'm trying another one. Let's go. All right, let's give you one more look at this. Can you stand it? One more. Okay, 3 steps to matrix algebra. 3 steps. First step, write it like a matrix. All right, so here we go. We've got 2, 1, negative 2, 4. 2, 1, negative 2, 4. So we take the coefficients, the numbers, makes up my first one. My letters, my variables, make up the middle one. And then my answers, they're on the end. All right. Once you get into matrix form, that's your first step. Second step is to grab this 2 by 2, and we're going to find its inverse. Let me just pull him up here where we can work with him. Okay, we got to find the inverse. And remember, every inverse is made up of an outside and an inside. Outside is always a fraction, 1 on top. The determinant makes up the bottom. So determinant, let's run it. 2 times negative 2, 4 times 1. So it looks like my determinant is going to be a negative 8. So I got 1 over negative 8. Let's get the rules for the inside of the matrix. Inside, made diagonal trades places. Negative 2 goes up, positive 2 comes down. Negative 2 up, positive 2 down. These stay put, but they just change signs. So positive 4, negative 4. Positive 1, negative 1. So this is my inverse. This is my inverse of my matrix. Grab this inverse, and we got to multiply it by the answers. Let's get it way up high. So 1, negative 8, negative 2, negative 4, negative 1, 2. So we're grabbing that one, the inverse, and we're going to multiply it times our answers. It's like 7 and negative 6. Let me look. Yes, 7 and negative 6. All right. We know the rules for multiplying matrices. It's always the rows by the columns. So we're going to connect these rows with that column, and we're going to save that ugly fraction till the end. So don't even mess with him. We're going to save it, and we're going to get nice numbers to work with in here. All right, connect it. First row, hitting with the column. So you got negative 2, negative 1, and then our second row, negative 4 and 2. So you got your row that's going to connect with the column and your second row that's going to connect with the column. 7, negative 6, 7. Negative 6, 7. Negative 6. All right, here we go. Doing a little bit of math. What do we got? Negative 14 plus positive 6. I got a negative 8. Negative 28 plus negative 12. What is that? A negative 40. And now we've got it at the end where you kind of deal with it a little better. So instead of all this mess of numbers with the fraction, we cleaned all that up, and we're down to this right here. Let's get all this out of the way. Get our final answer. And you guys remember the secret at the end. Whatever number this is, you're just dividing by that. That's the secret. So we take -8 divided by -8 and -40 divided by -8. Oh, negative divided by negative equals positive. So it looks like both my answers turn out to be positive. 8 and 8 gives me 1, 45 8 gives me 5. So there you go. X equals 1, Y equals 5. And we write it as an ordered pair because we just solved by matrix algebra.